Hello, everyone. Thank you for joining my talk. Today, I'm going to introduce some of the work I have been working on, and also with a lot of maintainers within the Volcano community. So I will briefly introduce myself. So I'm Kevin Wang. I work for Huawei. I have been working on Kubernetes as well as scheduling relevant stuff for 10 years here. I have multiple roles in the community, including vice chair on the technical oversight committee of CNCF, and I am also co-founder and a maintainer for multiple CNCF projects. But today, my talk is all about the scheduling thing. So I'm wearing my hat of Volcano maintainer. Okay, so this talk I will just introduce our understanding of the modern, especially the AI cluster network thing, and why we need a HyperNode concept, and how we deal with the implementation perspective. So maybe for the background that we don't need to go through too much details, we have seen there are the scale of the model, especially the LLM, has becoming larger and larger, and we have seen a lot of big players spinning up with their own AI cluster to better support, including training as well as like inference, and some of the latest investment also starting working on the AI agent. So we can see that like for training, more and more people running the distributed parallelism pattern, including like data pipeline, model pipeline, and a lot of other data parallelism, model parallelism, and also pipeline parallelism, for example, and also like more and more LLM deployment would prefer like prefill, decode, disaggregation deployment pattern to improve the end-to-end throughput, and also trying to get lower latency. But we all know that there are kind of a lot of advanced requirement for the underlying network, trying to deal with the bottleneck. For example, in the early days, we may use PCIe, but the bandwidth of PCIe got some bottleneck, right, when we are trying to load a large-scale model. And also, for the orchestrator layer, scheduler layer, perspectively, you know that Kubernetes default scheduler is kind of part of the scheduler, and we have seen a lot of kind of challenge when trying to support both batch workloads, training, and as well as the inference, and which would result in, like, if your basically your ports are not well scheduled in a certain kind of location, the latency would be very high. So there are some of kind of example of the big AI clusters network architecture. Maybe this will not represent the all, but I think they are good examples. Like for NVIDIA, we have seen like fully interconnected AI cluster. For example, the AI link, the NVLink, trying to get very high bandwidth with zero blocking network. And also some of the players, some of the company, they prefer to design the network by themselves, like still reuse the span leaf idea, and to integrate with the InfiniBand, and also RDMA over Ethernet, right, Rocky. So, and also there we have seen the other kind of companies, they are designing their own AI cluster network. They've been more specific. So I'm not going into the details. I just want to mention that for the different kind of idea, different design of the network for the AI cluster, that actually brings the complexity and brings the challenge for the scheduler, for the orchestrator. And from users' perspective, we always want to have a kind of simplified way or unified way to deploy our workloads. So thinking about that, for the platform layer, we need to kind of find a way to define a good abstraction for the network topology, right? We have seen in the early days, a lot of topology was defined by labels, right? For example, when we try to define failure domains from node to rack, to zones, and even to regions. And that can also be kind of adopted for the performance domain, which is considered another kind of perspective for the topology, internode topology. But is that enough? We can dive into more challenges later on. And another thing is we need to try to find an efficient way to manage the topology information. So the topology typically are kind of coupled with the hardware architecture, with the hardware design. There's no kind of silver bullet to fetch the topology data from like underlying interface, right? So ideally, we want to find a way. And also, we know that it's hard to maintain all the implementations. So we'd better have some plugin mechanism to let users able to extend to implement their own. And also for the scheduling part, actually, if you have dive into the scheduler algorithm is implemented by upstream default scheduler, you would find out that actually it brings a lot of complexity when trying to implement GAN scheduling, bin packing, and also especially inter-pod affinity. Would result in a big performance issue. So we really need to find a more efficient way to implement that. So yeah, actually the label mechanism was introduced by upstream like back to, I remember, 2015 actually. The interpod affinity feature was implemented in 2016. And also like Volcano project, in the early days, it was a Kueue badge under Kubernetes scheduling SIG. We also introduced that, but the implementation is a little bit different. So I just want to give some comparison between these two mechanisms, why we eventually consider using another API instead of label. So label actually has more flexibility for you to define. You can basically define anything as labels, right? But we have seen, like previously in the ecosystem, like the different providers define different label keys, even for failure domain. So for performance domain, it's highly likely the similar result would run into. And also, so in other words, on the other hand, the API definition may have better, abstraction to unify that. And also, node labels are considered flat, right? No hierarchical kind of definition on that. And also sometimes the implementation will be complicated because of the flexibility. If we can predefine the performance domain, that would be much easier for the scheduler implementation to optimize that. And also we can easily introduce like the topology discovery with the API kind of life cycle. For labels, it's kind of always a lack of a standard implementation. So basically, everyone can implement according to their own understanding. Yeah, and also it would be hard for the admin managing their workloads when they are kind of migrating from one either a cloud provider or on-prem provider to another, because of the variety of the understanding of the topology definition. Okay. Oh, I just realized that there's some Chinese character, but that's fine. So the HyperNode design in the Volcano, we choose to use the tree data structure. So on the right hand, you can see actually it's just we're just defining as a tree node. So actually, one HyperNode here means it's just a node of that tree. You can kind of indicate whether the member is an actual node or the member is a HyperNode. And on the left is an example of a tree finally discovered in the cluster, and the leaf nodes are always the actual Kubernetes node, and the non-leaf nodes are always HyperNode. And with that, you can always easily to kind of define a tree inside the cluster, and also it's quite easy to have multiple trees for representing your underlying network topology inside the cluster. So with that, that's a kind of basic for the API, because for cluster admin, it provides the flexibility to easily, take a look at the, have an overview of the network topology across nodes inside the cluster. And also we can easily add health checking and on the HyperNode to make you easy to find out if there's any failure of the hardwares. And also we definitely use this data structure for the scheduler implementation. So with that, we can also enable the auto discovery for HyperNode for the network, basically the network topology discovery. We know that actually, even for on-prem clusters, there are kind of the implementation will fall into some of the typical types. So like for NVLink, you can use the Fabric Manager API, and also like the InfiniBand, they also we can try with the OpenSM, and there are many more other options. And with the cloud, we can go through the cloud provider APIs. So for Volcano, we have the Discovery Manager to help decouple the implementation of the underlying discovery and fetch the HyperNode data, and then basically create multiple HyperNode objects to let the scheduler parse it to become really a tree data structure inside the memory. With that, you are also able to implement your own discovery plugin. Currently, we have provided the UFM Discover and also Node Labels Discover, which is super useful because it's quite easy to convert from node labels to actual HyperNode API objects. And yeah, that's for the underlying HyperNode, basically the cluster network topology management. And also we are adding more detailed status monitoring for basically the network issues. So another very important topic is about the scheduling implementation, right? So the implementation in the Volcano is quite different with the Kubernetes scheduler because we always in-queue by pod group. That means when you are defining your own workload, it will always be created with a pod group, especially when you have a set of pod you want to, a set of pods you want to co-locate it in a certain performance domain. It's quite easy to be scheduled with Volcano because it goes into a single pod group, and it's quite easy for us to reuse the middle result, the result of the in-cluster allocation, and adopt to all these pods within the same pod group. I'm not going to the details, but if you go to take a look at our code, that's very clear. And also, another question the community have been discussing is about how do we deal with the hard requirement or kind of best effort. So in the cluster, if we go back to the definition, we tend to define that the node on the same level or layer inside the tree be considered with the equivalent performance. So with that, you can kind of define the highest tier allowed for your workload. You want to make sure them located under just one switch, or it's acceptable for the traffic go across to two switches. Yeah. So today Volcano's implementation, it's the best effort is by default. So we will always try to schedule all the pods to all the nodes under the same switch. If it's not possible, we will try the upper layer. And also for some of the workloads, both for training and also inference, you will define kind of the worst case that's acceptable for you. So that's why we have the highest tier allowed in the API definition. Yeah. So basically, if it's not going to happen, it will just fail if you said it's a hard requirement. And currently, another very important thing is about integrating with the ecosystem. So because we are implementing that as a feature of pod group, so we currently support multiple projects. So like for Kubeflow training job, it's quite easy to enable because it's the pod group is created automatically, and also like the Volcano job, they are the same. And the leader work set, we just made the contribution in last quarter, sorry. So it's also possible to use that. And Volcano recently started a new sub-project called Kathina, which is focusing on the distributed inference, and also that's kind of enabled by default with the network topology. And also we are reaching out to AI Bricks project to support pod group. So these are the two typical examples. With Volcano, actually, you can define, with Volcano Kathina, you can define the network topology requirement under the network topology field. And also for the Kubeflow channel, because it's creating the pod group by automatically, so you can indicate under the pod group policy. Yeah, we are working on to support more type of network auto discovery, and also we are working on to support more workload types. And also, I would like to highlight that actually, if you are not using the scheduling functionality, you just want to kind of simplify the view of your cluster network topology. Actually, you can just install HyperNode controller and the HyperNode CRD to your cluster. It will bring you a unified view of that, even though you are using the default scheduler or together with the queue. Okay, so a little bit more about the new projects. I will just give very quick. So the Kathina project, we introduced a new workload definition to support preview, decode, disaggregated deployment pattern, and also we have a reference implementation to automatically deal with the traffic routing to improve the latency and the throughput. You can visit the GitHub address for more details. And we also just started to investigate the AI agent. So this is a very early stage project. We also integrate with Agent Sandbox, but also we are trying to implement with more scheduling perspective optimization, as well as bringing awareness about the session from the user of the agent. So yeah, I'm just stop here to recap all the things I have covered. And if you have any questions, this is the time. Thank you.
So I saw a lot, so the daemon, there we go. From the slides, I saw that the daemon takes into account the network topology, but does it also take into account uplink speeds, NIC speeds, anything performance related, or is it just the topology?
Yeah, the topology is the kind of first step. You need the topology information to have a more optimized scheduling result. With that, it makes you possibility to optimize the actual data routing. But it also, if you want to kind of optimize end-to-end, you still need to integrate with the libraries, basically the NCCL libraries. So we are, that's also one of our future plan. We are trying to figure out more details, any like more information or downward API policy we need to define to let the library know, and so they can use that information to optimize their route.
Thank you. And then do you see those dimensions making their way into that number that you call a tier, or would you have a different key value for that?
That one we still need to figure out more details, but currently most of the end users within the community, they just use tier to define the level of the performance. Like they always define tier 0 for the highest performance.
Oh, so tiers is not necessarily hops?
Not necessarily. It's just a simplified mapping. Yeah.
Thank you.
Can you expand on the hypercontroller CRD and the node label discoverer? Basically, if you're using a cloud provider, like you said, the labels are really flat. And for example, GKE has the super block sort of representation of, how the VMs are co-located and all of that. And like, does it already work with these cloud providers, or like, should we do something to basically, so let's say if I install the hypercontroller CRD just for node discovery, what would I, as the user, need to do to basically, get that?
Yeah, so we have actually a link, a document, user document with all the details for the network topology awareness. And you can find out that, so define your own configuration, what the labels you are looking for, and convert it to the HyperNode.
Okay.
Yeah.
And so this assumes that the nodes are already available. Like, so if you're relying on on-demand capacity, the labels only show up, right? Like, so taking the very specific example of GKE, right? The superblock labels are basically UUID. So it's basically the key is superblock and the value is some UUID. And like some of that discovery can only happen, on demand when the nodes spin up. So I'm just trying to contextualize, how this would work in that setup.
Yeah, because even the node is not there. Actually the pattern of the node labels it's kind of defined, right? Because they always have the same key, right? So basically you can group by key.
Okay.
Yeah.
Cool. Thanks.
Any more questions? All right. Thank you for listening.